Hello everyone, my name is Akash Prakash. I'm a first year AI/ML student. Today I'll be trying to give the algorithm for the QR decomposition of Gram-Schmidt method. So let's get into the code. Before understanding the algorithm, there are some key concepts that we should remember. First is orthogonalization. Orthogonalization makes vectors perpendicular to each other. Second is normalization. Normalization ensures that vectors have unit length. The third concept is Gram-Schmidt process, which is sequentially orthogonalizing and normalizing columns. The fourth concept is result. A is equal to Q dot R, where Q is orthogonal and R is upper triangular matrices. These processes systematically converts a given matrix into its QR form while preserving its structure and properties. Now let's get into the code. The first step of the code is to define the function and the inputs. We have defined a function called QR decomposition. The function takes a matrix A, capital A, as input. N is the number of rows and M is the number of columns. The second set of code is to initialize the matrix. We have capital Q, U and capital R. Q is to store the orthogonalized column of matrix A. U is an intermediate step for orthogonalization, and R is to store the upper triangular matrix. The third set of code is to orthogonalize the first column. The first column of the matrix A is directly used as U. To normalize U, to make it a unit vector, we store it in capital Q. So next we are using for loop in order to orthogonalize remaining columns, Gram-Schmidt process. The outer loop iterates over column of A from the second column onwards. The inner loop projects A onto the already orthogonalized Q. Now we subtract projections to make U orthogonal. In order to construct the upper triangular matrix, we commute R as the dot product of A's column and Q's orthogonal basis vectors, which is again done using the for loop. In order to get the output results, we get the next set of code. We have to print it, which is print the Q matrix is print Q, print the R matrices and print R, where Q is the orthogonal matrix and R is the upper triangular matrix. And finally, for input handling, we give the next set of code, which is A is equal to np.array eval of input, and then finally we call in the function QR decomposition. The input matrix A is passed into the function, and in this way the code would get complete. And this is the algorithm for QR decomposition using Gram-Schmidt method. Thank you so much.